The next problem we're going to discuss is number 16, in which we're given four functions, and we would like to find what's the total number of intersections, which are points lying on at least two graphs of these functions. So how can we start? We have four logarithms, and they all look similar, and they all related to each other. So we can actually look for what's the relation between these functions. So the first one is y equal to log 3 of x. And I think this is the function which we all know how to draw. If x is equal to 1, my value of it passes through point 1, 0, and it passes through the point 3, 1, right? So if I'm going to draw it on my graph, then it's going to look like this. This is coordinate 3, 0. So this function is equal to that, and that one is actually equal to log x over log 3. So we can see that they are reciprocals of each other. And we can plot the second one in purple.
So that's tricky. How do you plot 1 over something? Right? Well, first of all, you should know there will be asymptotes. Because
when the green graph crosses 1, 0, the purple graph goes to infinity.
right.
So this will be our asymptote. So whenever x is very close to 0, this tends to a big negative number. So when I take the inverse, it's going to be very close to 0. So this part of the graph is going to look like that. And if my x is bigger than 0, then what do I have?
You start from the top, yeah, and then it should cross its reciprocal at the place where y equals 1.
So it should go through 3, 1.
You should go through this point too, right? And it goes that way. So at least we already found one intersection.
No, we found 2.
And this is the second one, right? But we didn't compute its coordinates yet. Let's take the next one. It's going to be y is equal to log 1 over 3x, which we can rewrite as log x log 1/3. And log 1/3 is log of 3 to the negative 1 power. So I can rewrite it as negative log x over log 3, right? So it's going to be basically negative of the first function. So how we draw the negative?
You just reflect it across the x-axis.
Yes, so it's going to look like this, right?
Yeah.
So the last function is y is equal to log x 1 over 3, which is log 1/3 over log x, which is negative log 3 over log x, and it's going to be negative of my second purple one. So if I look at my purple one, I would like to make a graph symmetric with respect to so we'll have an intersection here, intersection here, intersection here.
So we have 5 of them, right?
Yeah, one is here. Yeah, so from the graph we get 5 intersections, and this will be our answer.
Now this is very tricky. Do they intersect at 0, 0? That's the very tricky part. It's so, from your graph, it looks like they do.
Yes, but we know that x is strictly positive. So at 0, we can think what happens there, but at the computation, you don't need to consider the point.
No, I don't think that's correct. They don't even need to give you x equal to 0. You should never consider that because that's not part of the domain.
Yeah, because if we look at like log, take one of the functions, like the purple one, right?
Mhm.
Log 3 over log x. That's never going to be equal to 0, right?
Yes, the right way to say it's never in the domain.
Because you can't do log of 0.
Right. So you should put an empty circle over there to be really correct, right? Because your graph doesn't go through there. Yeah. So you have 5 of those. Good.